Hi, I'm Zahra Ashktorab, and I'm here to present the work we did on effects of communication directionality and AI agent differences in human-AI interaction. HCI researchers have done a lot of work on determining what can lead to successful collaborations in human-AI collaborative settings. One factor that has been explored are social perceptions between collaborators. One opportunity for studying user perceptions of AI agents are cooperative, partially observable games. These games require players to cooperate with one another, especially since there are aspects of the game that are only partially observable. So here, the AI agent has a target word, cold, that the user does not know about, but the AI agent will send a clue, and the user must interpret that. The user responds with a guess, and the AI agent sends another clue, and then at some point, the user might win the game if they guess correctly. We were really interested in investigating the direction of communication because there are scenarios in which the human must provide clues to the AI agent, and those clues will differ than the clues that an AI agent provides. In prior work, we were investigating interactions with just one model. We wanted to investigate whether social perceptions changed and varied with different models. We had a total of 6 models, so for each of these models listed here, we had a guesser and a gander. We will refer to these models as model A, B, and C because in our findings, we don't want to overgeneralize. If, for example, the users win more when they play with model B, that reinforcement learning is the best model for all human-AI interactions. This is another example of gameplay. This is with model A. The target word is vanilla, and here you see the AI providing different clues: fruit, chocolate, flavor, bean. In another example, this is model B, and you see that the nature of the clues are different. This is model C, data-driven. So we were really interested in how the direction of communication, various AI agents, and the perception of their partner's AI identity affect social perceptions of their partner and also impact gameplay outcome. We ran an experiment in which participants were assigned to different conditions. They were told they were either playing against an AI or a human. They played as a guesser or a giver, and they were assigned to one of the models I just described. They also played 10 different games, and then they took a survey on intelligence, rapport, likability, and then an AI score. Our findings showed that for one of the AI agents, model A, when participants believed to be playing against an AI, they found their partners to be more intelligent when they were playing the role of giver than when they were playing the role of guesser. Prior work has shown there to be bias against bots when they disclose their identity, but in our experiment, we observed the bias against the AI to be more present when users play the guesser versus the giver. One potential explanation for the differences in social perception could be explained around a user's feeling like they are in control when they play as the giver and not when they play as the guesser. When users played the role of guesser and believe their partners to be an AI, the model C agent is perceived more positively in likability and rapport than model A and model B. Of all 3 agents, model C has a higher average score and lower average number of turns in both model A and model B. One potential explanation for these results could be that it is a better model than the others, and it is better at giving clues that are interpretable by users. We also found that users took more turns to win when interacting with a human and wanted to see why. We analyzed the clues that they gave for when users felt they were interacting with an AI or interacting with a human and found these themes. We found repetition when users thought they were interacting with a human. They would repeat words to kind of signal that it is an important word. We also found users were using relational words. So, for example, when the target word is cold, they would use hot and then use the word opposite to indicate that hot is the opposite of cold. And we also found suggestive words when users felt that they were interacting against a human. Our results highlight that it's not enough to evaluate social perceptions with one AI model, as the results across all of our AI agents varied. A lot of researchers in the Chi community and researchers who are investigating the relationships between humans and AI might think that it's enough to investigate with one AI agent, but our results seem to suggest that it's important to investigate with various AI agents. We also found that in human AI interaction, the directionality of communication has an impact on the perception of an agent, and it is important to consider the implications of directionality when investigating human AI interaction. Thank you for listening, and I'll be happy to take your questions.